Okay. Now, weather is a collection of data at a single time point. Climate is the average over long periods of time. And so depending upon where you are, you can have different kinds of climate. The tropics near the equator are very hot. They have lots of rapid updrafts of air, and you get lots of showers. And so when I lived in Puerto Rico, you almost had a rain shower almost every day. It would last 10 to 15 minutes, and it would be over. But that's what tended to happen. We are in the middle latitudes, okay? The middle latitudes are like in the US, and so what really typically happens if you're in the middle of the country where there's land, this is what happens. The winters get cold, the summers get hot, and you have large swings of temperature in the middle latitudes between the seasons. The tropics, the temperature stays about the same all the time. There are exceptions in the middle latitudes. If you live near a coast, and my dad was in the Navy, so we were always living near the ocean. We either lived in San Diego or we lived in Virginia Beach. In both of those cases, because the water was there, remember water heats slowly, cools off slowly, it kind of buffers. If you live near a coast, it does get hot in the summer and cool in the winter, but it never gets really cold and it never gets really, really hot because the water can buffer the temperatures. In actuality, if you take a look at Hawaii, Hawaii on the map is closer to and should have lots of swings back and forth, but it's surrounded by an ocean which keeps the temperatures nice and constant, and so they have wonderful weather where they are because they're surrounded by water. But if you're in the middle of the country, you're going to be as hot in the summer as you can be, and you're going to be as cold in winter as you can be. Okay? We tend to have areas where it's rainy and dry because of the types of air masses that move in, whether wet or cold in the middle latitudes for us. Now, the climates do change. And so, some people don't believe in climate change. Okay, well, historically, climates are always changing. And we have records of it becoming cooler, and then warmer, and then cooler, and then warmer. And it has gone up and down through the entire written history, recorded history, and even before that. One of the biggest climate changes that were close to us in time were the, and I hate this, we call it the Ice Age, but it was really ice ages. There were periods of time where it got cooler and warmer in a very small span. So it wasn't just one freeze and one thaw, it was several. And unfortunately, the movie Ice Age kind of gives us this idea it was one event. But before and not too long ago, there were as much as almost 2 miles of ice on top of what would be the city of New York or most of Europe. 2 miles thick of ice. Today's climate wouldn't allow that to happen, but in the past, it did. And so, if I take a look, it was really cold. The average temperature was below freezing for the entire world. But as we move closer to today, it got warmer. And then it cooled. And it got warmer. And then it cooled. And it got warmer. And from about 1900 to now, we seem to be trending upwards, the average temperature. And so, some people claim that the climate isn't changing at all. That's it. Okay? Those people that admit that there's absolutely no change, I really can't listen to because they haven't looked at any data to actually see what's happening. Okay? Now, there's an argument that says, okay, the climate is changing, but it's been changing all along. Okay, I get that. Okay, they have at least recognized that climates do change over time. I like that. That's good. They know something. All right? Now, here is what people have been talking about, and scientists have been trying to present data of what they've been finding. The changes in climate have happened over long periods of time. And in the past, that fluctuation up and down, I equate it to like driving, it was like driving a car at about a mile an hour. Okay? And over a very long span, even when we went up and went down and we changed climates, it happened really slowly. Okay? And that's what we are used to. That's what the record says. If I equate now the types of changes that we see that started at around 1900 to now, the speed of the change that is happening is closer to about 100 miles per hour. So all of a sudden, we have changed from a historical movement of incremental change to a time period in a very short time, we're talking large changes. Okay? And the terminology of global warming was really a bad nomenclature. Climate change is probably a much better nomenclature. And so there are areas in the Arctic and Antarctic in which there were glaciers that were huge and shelves of ice that went way over the water and not on top of the land, where now the ice is shrinking and these pieces are falling off. And these pieces are like the size of states that are breaking off. Okay? And there's a lot of evidence that things are not the way it was even a decade ago or 2 decades ago. Places in Russia where you have frozen ground that have been frozen for hundreds of years are now soft and squishy and not frozen anymore. It's been frozen for lifetimes, and now it's not. There's differences. There are places that seem to be a little bit warmer, and then there are places that seem to be a little bit cooler and more rainy than they're supposed to be. And so there are changes that are happening. Now, the argument that happens is that, are we affecting it? Okay? Now, we know climate's changed and have changed in the past, but we're not sure why we had that slow incremental change. Here are some thoughts. Some people think that, well, the orbit of the Earth may have changed shape. And so how much sun we get versus the year might change, or the tilt is not 23.5, but the tilt might move, and so we get more extreme weather, which might change the climate, or we might, our orbit might be a little bit closer or a little bit further away from the sun sometimes, all of which are speculation. We don't have any measurements for. We think that might affect it, but we're just not sure. We don't know why, but we do know climates change over time. And so, not a good explanation has been made for this. Okay? Now, here's the data that a lot of people are concerned about, is this data particularly. And it really began with the industrialization. And so, you see in historical records, we measure the temperatures, and over time, the temperatures have risen. Okay? And that's pretty established in all the data keeping. All right? Now, here are some arguments. All right, so way back when in 1900, we were making temperature measurements in all these different places. And as we have grown and become more industrialized, the cities have grown and our measuring places are stayed the same. And so the thermometers are closer to cities. Cities are hotter. We're seeing the cities, not necessarily the overall atmosphere. Okay? Some people argue that. Some people argue that the thermometers weren't as good way back when, and now they're better, and all we're seeing is differences in how we measure. Okay? And so they argue that there is some sort of error in how we take the measurements, but there is definitely a trend upwards. And the movement of 2 to 3 degrees is huge if we talk about the average of the entire Earth. So temperatures are rising on average from the globe. That's what the data says. Although the data that is in the public domain, that most of the science that the U.S. funds with our governmental dollars, we put it up in public databases. There are movements now to take that data away so that we don't have access to it, so anybody can take a look at it. There are places and people that are trying to remove that data so it can't be looked at. All right, here's another set of measurements. We've looked at the concentration of carbon dioxide. Carbon dioxide is produced when you burn wood, when you burn gas, when you burn coal. And so as we've become industrialized, we have produced more CO2 through use of engines and manufacturing processes. And what we see is the curve of CO2, the concentration of CO2 is going up. And remember, insolation is all that energy that comes from the sun. It gets absorbed, it gets re-radiated, and the atmosphere gets heated up, right? And that heat will eventually go to space. Well, all the gases in the air trap that heat, but if you put more molecules in the air that trap more heat longer, you'll heat up the Earth more over time. One suspect is CO2. All right, here's an argument against this kind of analysis. All right, here's a situation. Children drowned more often in outdoor pools during the summer than they do in the winter. Okay? Agree with that statement? That seems logical? All right. The consumption of ice cream increases in summer than it does in winter. Thus, ice cream causes kids to drown in pools. Yes? Both of them go up in summer, right? So one causes the other, right? What is this an error of? Yeah, the cause. It may be correlated. They both go in the same direction, but there's absolutely no linking that you could conceivably make that would make those two things put together. Just because they're going up in the same direction in the same time period doesn't necessarily mean that they have anything to do with each other. Okay? And so the rise in temperature and the rise in CO2 could be possibly just coincidence that both of them are going up in the same direction. The only argument to that is that we know that carbon dioxide is one gas that, if put in the atmosphere, can increase the insulating effect of heat escaping the atmosphere. And so, yes, they're rising in the same direction. It could be just a coincidence, but there is a scientific principle that can relate rising temperatures to that particular molecule. Now, we are really concerned about CO2 because it's produced in a lot of things, from our cars to all sorts of things. But CO2 is the largest fraction of what we call greenhouse gases, gases that can trap heat. Makes up about 55% of the emissions. But some of these other gases that are also given off are greenhouse gases, and even though they're a smaller percentage, they actually can trap heat more than carbon dioxide. And so a lot of people are concerned about carbon dioxide, and so be more fuel efficient, stop using electricity because CO2 is produced in that. If you have to use CO2, then pay an extra fee so that you can make the CO2 and feel good about yourself. And so there's lots of different ideas about CO2 and trying to reduce how much is given off. Ooh, what are the CFCs? What did we learn about CFCs and why were they bad? Do you remember? It reacted with something in the air called the ozone. So CFCs were bad because of ozone, but CFCs are also greenhouse gases. They can make the heat absorb. Methane, okay, natural gas. This was an interesting one. I remember there's a group that criticizes the government, and they look for wasteful spending. And a lot of times they look at like scientific studies. And they identified $2 billion because it was given to through the National Science Foundation to study bovine flatulence. And they said, this is a waste of money. On first glance, I probably agree. Why would I give somebody $2 million to study about cow farts? Okay? That doesn't seem really great. But here's the data that came from that. We have on Earth more cattle than ever before because we're raising them as food. And so if you allow cows to be in nature, the balance, we would have a whole lot less cows roaming around. But we have large concentrations of cows. In their processing of their grains and grasses, they produce gas, the gas methane. In actuality, the amount of gas that is produced by the livestock is a significant contributor to gases that are contributors to, or potential contributors to, gases that could trap heat. And so, that was interesting. What do we do about it? Okay. What in the world do we do about it? One, we could become more fuel efficient. Okay? If CO2 is causing an effect, all right, then maybe we can reduce this. If CO2 isn't causing an effect, reducing this is not so bad either because everything that we're burning or almost everything is a non-renewable resource. That means we're going to run out of something. And so eventually we're going to have to stop. But we could destroy ourselves if we are too dependent. CFCs we've already talked about as being bad. We've already tried to ban them. All right. Am I going to reduce the number of cows and not have as many McDonald's and Five Guys and Burger Kings around? That's probably not going to happen. Okay? And so there are some things that we will do and some things that we won't do. Okay? And if we reduce some of these things, we might have to turn to alternative energy sources that might cost a little bit more, and so it's more expensive. And some people don't like to do that. But if we pollute our atmosphere to the point that it doesn't work like it should, then it doesn't matter what we do in terms of our monetary thriftiness. Okay? All right. Here's one thing that kind of confuses me. All right. Adam and Eve in the garden. God walked with them, talked to them, right? And he gave them a few rules. It wasn't a whole list. It wasn't even the 10 Commandments. It was just a couple things. Take care of the garden. Be fruitful and multiply. Right? And, just a few things that they had to do. All right. I've heard sermons about be fruitful and multiply. Church, have you? Yeah, I've done that. Do you know what I've never heard spoken about in church? Take care of the earth. It was one of those commandments that literally the voice of God told us to do. But as Christians, we tend not to even touch that subject in our sermons. A lot of times, at least my Christian friends, kind of look at people that want to save the environment as being weird, as being cult-like, as that's kind of an oddball thing. Now, I'll agree, someone who wants to go tie themselves to a tree to save it because it might get knocked down seems a little weird to me. Okay? And so you can be extreme in terms of saving the planet. But where in the world did we stop and forget about something that God told us to do? Take care of the earth. Be reasonable with how we use it. Okay? He gave us dominion over the earth, not the earth over us. So the nature is not going, it should not be dictating to us what we do, but we should be using it wisely. I think one thing that comes to mind that could lead us down this road is that when sin entered the world, not only did we fall, but creation fell too. And creation will eventually, if you read the back of the book, be destroyed. We will, at the end, have the destruction of earth, and within the destruction of heaven, and we will have a new heaven and a new earth, and we will reign with God. Ultimately, right? Just because it's going to be destroyed because it's bad doesn't take away our responsibility to at least try to take care of it. And we, as a church, and that's an absence I see. I don't necessarily think we need to be way out in left field on it, but it should be recognized as one of those things that God told us to do. How do we do that? And how do we behave the commandments that God gives? We're not just Christians because we obey the ones that we like and ignore the ones that are there that we don't like. And so I think the irony is the absence of even considering that. And so the talk about climate change, whether it absolutely is affected by man, okay, it could be the fact that this is the natural time in which the climate is swinging in one direction. Could we have contributed to that? Okay, if we're creating any pollution, we're changing what's around us. Is the particular pollutions that we're putting out, could it influence? Maybe, maybe not. And if it might be, is there a way for us to do things that would be better for the environment rather than ignoring something or denying something which could tip it over into a very, very bad place in which we can't recover?